Okay, so today in honors pre-calc, the bouncy ball lab is the first thing I want to discuss. Why? There's a test tomorrow. Well, because after the test tomorrow, your only homework is to work on this lab. All right, so let's everybody. I totally understand that the file that you have right this second looks very strange. It's like when I just tried it again. I tried to convert this to a PDF. It takes all of the images and like they can't read the images for some reason. Normally it can, but it makes it so you can't like really see all of these things. So if you just have a blank Notability doc where you're going to start your lab, I'm totally okay with you can just use a blank Notability doc to do this lab. And if I were you, I'd have that open right now so that I can give you some hints. So first off, for the bouncy ball lab, like everything, you have to have a purpose. And all I ask is that you summarize the purpose in your own words. So if I were to generalize, what is the purpose of this lab? It's to figure out the total distance that that ball would bounce from 1 meter. You drop it from 1 meter. And I know it doesn't even say 1 meter. It's sometimes in the lab it says 2 or 3 meters. I find that it would be really hard to hold 2 meter sticks up and do all of that. So I just had you drop it from 1 meter. All right. So, and then the only other by on your purpose is by using an infinite geometric series. Now, if you didn't include that, that's going to cost you points because the point isn't just to see how far a ball went. It's to also learn to use an infinite geometric series. Okay. Now, the sketch is one of those things that you have to have. You know, it's got a category for that on the format for all labs. And make sure you label like the X and the Y. But I want to talk it over because I think once you see the sketch, you'll understand a little bit better. Let's say that this is your ball. And it isn't good at the end there because it's actually higher on after a bounce, which that's like flubber, doesn't exist. But do you get that there are 2 trips, both up and down, for every one except the first one? So the very first trip there doesn't have a double. All the others have a double. So this is a infinite geometric series, but it's a little weird because it's a double. And I want to know the total distance that the ball went. If it was as simple as 1 meter, started with 1, and then it went to a half a meter, and then it went to a fourth of a meter, you know what I mean? Half of the half. Do you get that we could add that up with that little formula? It'd be really simple. But would ever any ball actually have those numbers? 2 reasons. Number one, it's never going to be perfect of a half. I mean, you could probably build a ball to be perfect a half. But second of all, it has to go down and up. So it wouldn't be 1/2. It'd be 1/2 plus 1/2 plus 1/4 plus 1/4. You get what I'm saying? All right, so it's not super hard, but just factor that in. Some kids just try to make this way too simplistic and go, oh, it's just geometric series. A is 1 over, and the formula is S sub infinity, A over 1 minus R. In case you haven't written that down yet, you need that formula. And it's just 1 is the starting, and then it's 1 minus the R, which is a half. And I know yours might be like 0.6 or something, but and then is it that simple? No, it's not that simple. But it's not that much more complicated. Because it does go all of those distances. It just goes some other distances too, because it goes down and back up again. Or up and then back down again, depending on how you want to say it. Okay, so there. Honestly, this is just like a test question. It's just that you got your own data. And honestly, it's not that much harder than a test question. Okay, so this is your simplest lab that you have ever had. Don't overthink it. If you're thinking it's super hard, talk to somebody about it. It's just pretty simple. You're adding up a geometric sequence that's decreasing and therefore can be added up. Do you get if it had been a geometric that was increasing, it wouldn't be able to add it all up because it would go to infinity? All right. So that's an important thing, and I'm starting now the process of reviewing for your test tomorrow. One of the things that we're going to talk about is when can you and when can't you add up a geometric series. First of all, only geometric infinites can possibly be added up. Arithmetic series will never be able to be added up. Not to infinity. I mean, you can add up a certain number of terms, but you can't add them to infinity. All right, so if it's only geometric, some kids are going to say, well, the reason you can't add up other geometrics is that it'll add up to infinity. No, I will not accept that as an answer. That's not a correct answer. Because there's only one formula that adds up to infinity, right? We've only learned one infinite geometric formula, and it only works under certain circumstances. That's why the other ones won't add up to infinity, is we don't have a way to do it. And besides, if I say something adds to infinity, you're using the word infinity wrong. You know what I'm saying? You cannot total it is a better way to say it. But when are you allowed to use this formula anyway? This is A over 1 minus R. When is it legal? And don't say R is less than 1 because that's technically wrong. You're closer, but still wrong. Yes? That would be true. What's another way to say what he just said legally? It's another way to say, why can't we just say R is less than 1? Well, then couldn't R be negative 20? And then it wouldn't work. Can you have negative R's that would still work? Yes, you can. But they have to be between what and what? 0. If it's between 0 and 1, it isn't negative. R has to be between 0 and 1, or between 0 and negative 1. That's another way to say it. Okay, that's the only time this formula works. So your R, which is your common ratio, has to be a decimal, and it could be positive or negative. That's not officially right, because decimals, everybody thinks decimal, like 0.25, but 25 is also a decimal. A lot of people don't know that, but it's true. So you can't just say it's a decimal. Well, so is 25. And that wouldn't work. It has to be less than 1. But that's not safe to say either, because then you're involving big negatives. So, 2 ways to say it. R has to be between 0 and 1, or another way you could say it is R has to be between negative 1 and 1. The only weird case that brings up is, what if R is 0? What if R is 0? Would it still be able to add up a sum that starts with, let's say, 20 and has R as 0? I'd like you to take that case. It starts with 20 and its R is 0. See if you can add it all up. Can you add it all up? Yeah, you can. Does it still follow the formula, though? Well, what's our A? 20 over what's our R? So it's really 20 over 1, which is 20. Does this really add up to 20? Yeah, because if R is 0, what's the next term? 0. What's the term after that? 0, 0, 0, 0. So it would add up to 20, wouldn't it? So even an R equals 0 works in this formula. All right, would R equals negative 6 work in this formula? No, it would not. Would R equals negative a half work in this formula? Yes, it would. Okay. All right, I think I've beaten that to death. So let's move on to something else that you'd have to know. So imagine for a moment that we've got a sequence and we have the first term of it. That's the easiest kind. Let's say it's 6, comma, and then I don't know what happens, and I don't know what happens, and then all of a sudden it's 38. And it keeps going. Now, could this be arithmetic? Could it be geometric? It could be either one. I didn't say which one it was yet. Okay? What I'd like you to do is use the proper formula to figure out if this is an arithmetic sequence. Figure out what the next one is. So I'm going to call that the first, second, third, fourth, fifth term. If it's arithmetic. Now, if you used guess and check, I would not give you credit. You have to show me algebraically how you can find this. So do not try to go, oh, I think you can add 18. Don't do that. Got to be able to show me algebraically. Now, hint, you're going to have a formula sheet, and I'll be your formula sheet right now. So your formula in this case is S sub n is equal to A plus D times n minus 1. That's the key formula. Comes off the sheet under arithmetic term finder. Remember, the formulas just are listed as arithmetic or geometric, and you have to know what they mean. I hope you know that that one's the term finder. The more complicated one, the more complicated formula is the one that adds up a bunch of terms. But if I want to find the fifth term, I've given you the right formula. So write out what you think the equation is. Would you please share it with the kid next to you, and let's see if you guys just don't even have to solve it. Just find the formula first. Like, stick the numbers in the right spot. See if you can figure out what you're supposed to solve. See if you guys have the same formula to solve. There's a smallish number of kids today because there's a speaker. So if you could just compare with the kid that's kind of nearest to you, that would be good. Hint, you don't know the common difference. You don't know D. That's what you're trying to find, really. Once you find D, it's going to be easy to get the fifth term. All right. Heard a lot of good conversations, and they were typically like this. That's the what term? That's the fourth term. 38's the fourth term. So then the amount it started with was 6. That was really nice that they gave us that. Plus the common difference. I don't know the common difference. A lot of times people get stumped right there, but you're just going to solve for D. And then N has to do with this. That is the fourth term, so it's 4 minus 1, which makes 3. And then I have 38 equals 6 plus 3D. Then I'm going to subtract 6 and divide by 3. So then I have 32 equals 3D divided by 3. Divided by 3. And whatever 32 thirds is, that's my D. Yes?
Are we going to have a calculator on that?
You are not. We have determined that.
Do you want us to write that answer as 38 plus 32 thirds? Right?
Yeah, absolutely. And then simplify it, because you can do that. Like, these are small enough numbers. Do you get what I'm saying? Since you're not going to have a calculator, we're not going to expect you to, like, go do this with really weird square roots of 7, and, you know, like, you'll get numbers you can handle. All right, so then I agree. This answer is 38 plus 32 thirds. And yes, you'd have to be able to find the common denominator and add those together. Now, an easier way, though, in my opinion, is figure out what 32 thirds is as a mixed number. So let me think. That's really close to 11, so it's what? 10 and 2/3, then wouldn't I be able to just take 38 plus 10 and 2/3? Because this is 10 and 2/3. If that's 10 and 2/3, sorry, it went off the screen there. 38 plus 10 and 2/3 is 48 and 2/3. 48.6 repeating if you wanted to do it as a decimal. Does that make sense? Okay. Now I might give you one that's more difficult because it won't give you the first term. If this is geometric, and I've given you the second term and the fourth term, I need you to tell me what the next term will be. Again, fifth term. But it's more tricky because I didn't tell you the first term. Okay. This time, you need a different formula. There's usually somebody who's got it. Anybody remember this? Back row. You are so close. Times. That's a times. A times R to the n minus 1. But don't worry, you'd have had a formula sheet and you'd have been fine. Welcome. So I'm partway through recording the review for the test, so you may want to watch the beginning. All right. Okay. Right now, what they're doing, and if you can jump in here, I've given them the second and the fourth terms in a geometric sequence. And I'm asked them to figure out what would the fifth term be. The trick is, you'll realize I didn't ever tell you A. And so you don't know A and you don't know R. But you can write two equations that both have A and R in them. And you'll be able to solve it. Two equations. Why? Because you have the second term and you have the fourth term. So you can write two separate equations for that both have A's and R's missing. All right, I'm going to pause while you give that a shot. Okay, so I'm going to write the first equation. I'm going to use the 8. 8, I might as well put it right underneath the equation. So I'll use this equation. 8 is A. Well, I don't know A. Just put A. Times what's R? I don't know R, so put R. And do I know N? Yeah, it's the second term. So if that's the second term, then it's a 2 minus 1, which is a 1. And so 8 equals A times R. Make sense? The other one is 40 equals A times R to the... That 40 was the fourth term. So 4 minus 1 makes 3 up here. And now, if 8 is equal to AR, then I could solve for A or R. Doesn't matter. I'm going to solve for A. That'd be equal to 8 over R. Then I could put an A right there. A is, I just solved it right there from the first one, 8 over R times R to the third. You should have been able to do this. 40 is equal to 8R squared. Divide by 8. And I have 5 equals R squared. And R is the square root of 5. True or false? Kind of true. There it is. Plus or minus. Is that important? Yes. R's can be negative. So if I take and multiply by the square root of 5, and then times by the square root of 5 again, it's like I multiplied by 5. You know, square root of 5 times the square root of 5 is square root of 25, which is 5. And 8 times 5 is 40. So yes, times the square root of 5 would work, but so would negative the square root of 5. Why? Because when we square root a variable, we have two answers, because it's the absolute value of R. So plus, so it's square root of 5 first, and then this absolute value leads me to believe that there'd be two answers, square root of 5, and R is negative the square root of 5. or plus and minus the square root of 5. If you forgot the negative, would you mark it against us? Absolutely, because it could have been negative. Yes?
You just use the term finder equation. Find R.
Did you get the same exact answer? Plus and minus the square root of 5. Okay, awesome. Then there's another way you could do it, and absolutely that would work. I'm trying to set you up with something I know will work on the test, and sometimes there are other ways, and I'm not saying your other way wouldn't work on the test, but I know mine does. So, all right. And I mentioned to class verbally before I started this, my back is killing me, so it's a terrible excuse, but I want to get through a bunch more stuff, and I don't want to try to explore your way of doing it because I'm afraid I was warned this back when I was a new teacher, and I think it was good advice. Don't ever bring up a new way to do it on the review for the test, because some kids will conflate two things, and they'll take the new way to do it and put it with the old way to do it, and then it won't work. Know what I mean? So, but I can console you in this. As long as you show your work, I'd be accepted a different way. Okay, so what's next? We haven't talked about binomial expansions lately very much, so let's do one of those. Would you please take negative 3x plus 2 and do it to the 4th power, but that would be pretty long. Like, you know what? First, let's do a simpler one. We'll do a simpler one that we do all the way out. My bad. First, we'll just do this one. 2x minus 1, and we'll do it to the 3rd, and we'll do it all the way out. All 4 terms all the way. Then we'll do a binomial expansion where it's more complicated, but we don't have to do the whole thing. Like I might only ask you to find the 2nd term. All right, do this one all the way out. I'm going to pause for a second and then show you how you should have done it. Okay, let's see how you did. 1, 3, 3, 1. I've memorized that. Does that help you? No, but maybe you've memorized it. Some of you guys still chatting. If you could stop, that'd be good. Thank you. So here's how you could get that: 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, and how am I doing this? 1 plus 3 is 4. 3 plus 3 is 6. 1 plus 3 is 4, and then a 1. It always ends with a 1. And you could keep doing that even if there was 24, blanks you needed. But that's not the most efficient way. So let's talk about that. How could I have gotten this if this had been 13 and there was 14 terms? I wouldn't ask you to find all 14 terms. But what if I asked you to find the 3rd term? So let's talk about that for just a second. Let's say it was 6x minus 2 parentheses to the 14th, and I wanted the 3rd term. Everybody, just take a second. Do you remember it's not this, but let's say it was 10, choose 5. That kind of thing can tell you what the lead coefficient is that you start with, These numbers could have been found with something, choose something. Would you please figure out on the 3rd term of this answer, what coefficient would you have? It's not 1, 3, 3, 1. What is it? And it's not 10, choose 5. Yep. Just to help the people about the 3rd one, what would the 1st one have been? Nope. 14, choose 14. And how about this one? 14, choose 13, and therefore this one, choose 12. And then what is that? That is 14 factorial. Remember we had a whole day where the homework was mostly finding factorials and n minus 1 over n and the factorials. Okay, so then this is 14 factorial over 14 minus 12, which is 2 factorial, with an extra one of those, 12 factorial. That's how you'd figure that out. You have to know how to do that. Okay, so remember, whatever's the 2nd spot, that goes here. And this spot, that's the 2 numbers subtracted, the 14 and the 12. Okay, now, I'm not going to write it all the way out because I know this is 14, 13, 12, 11, 10, 9, 8, 7, etc., but it's going to cancel with the 12, 11, 10, 9, 8. So then this is just 14 times 13 over 2 factorial, which is really just 2. And how could you be expected to do that without a calculator? Because you should know how to do 14 divided by 2 is 7, and 7 times 13. If you can't multiply 7 times 13, you deserve to lose a point in honors pre-calc. Okay? Did you get 91? All right. Okay. Do we need to practice that more? Because we can. All right. 2 people are either saying yes or nodding. All right. We're going to try one more like that. So let's say it is 5x minus 2, and I want 7 terms, or sorry, to the 7th, which would actually mean there's how many blanks? 8 blanks. I'd like to know what the second of the 8 blanks would be, except do it all the way. As in, I don't want to just know what the lead coefficient would start with. I want the whole answer for the second term. Just that one. I'm going to pause for a sec. We find the second term of this binomial expansion. Got an answer or a question? Yes.
So, like if it asks for the coefficient, would that be like just getting like the blanks?
Good question. When I was saying coefficient, I was saying like what you start with. Like remember 1, 3, 3, 1? Like that kind of thing? That's what you'd start with. And then there would be another number you'd multiply by. So you're right, that's not the final answer for the coefficient. But it's like another way I could be asking this is, if you figured out Pascal's triangle, what would the second number in Pascal's triangle be? See what I'm saying?
Do you want us to solve it out with that?
Yes, I want the whole answer. So I think your final answer is going to be like, 25x to the third. Maybe it's negative or something. But figure out exactly what the whole final answer is for the second term. Don't just figure out, I hope by now you figured this out, that it's 7, choose 6 is one of the numbers you have in there. Right? Okay, good. I totally get you might have an answer that has like 5 to the 4th in it. I'm okay with you leaving a 5 to the 4th or something comparable in your answer. Okay. This spot, 12-minute warning. This spot would have been 7, choose 7, but I didn't ask you about that spot. This spot, 7, choose 6. That's 7 factorial over 7 minus 6 factorial, which is just 1 factorial, so it's kind of not even really there, with an extra one of those at the end. 6 factorial. That's the key. That gets almost everything to cancel. Only thing less is a 7. Raise your hand if you had a 7 as part of your answer. Good. Then, what else is there? Well, this one would be galloping through with a 5x to the 7th first, and then 5x to the 6th. Right here, it'd be 5x to the 6th. So yes, there is a 5 to the 6th in your answer. I get that that was too big for you to do without a calculator, so you'd have to leave it that way. And that same thing will happen on the test. Okay? All right. So then, what's the last part? This negative 2. The negative 2 has to go through, and it's negative 2 here, but that's to the 0. This would have a negative 2 to the 1. So there is a negative, so your answer is negative. And the way I would have left it, if I were you, is I'd have said negative 14 times 5 to the 6th, and then there's an x to the 6th. can't really have expected you to figure out 5 to the 6th and then times it by negative 14. That'd be just a massive number. You're not going to have a calculator on the test, but the numbers are also pretty nice. Like, in other words, if I had used 2, could I have expected you to figure out 2 to the 6th? Yeah, because you're just doubling, and you keep doing it, and it's 64. And it's not that hard. Okay, so if the numbers are easy enough, you should be able to do this. All right, cool. So, what else do you have to know? Well, we've covered a lot of it through that quiz, and I want to reiterate on Schoology, I haven't yet, but I'm going to in a minute, post the key for it so you can look over that quiz you took over the weekend and self-score that, all right? At some point, I will probably provide a Dropbox for that, but I haven't yet. But I'm guaranteeing that I'm going to put up a key. All right, so that's one thing you could do to practice for tonight. Getting sensitive to the fact that there's only like 7, maybe 8 minutes left in here. So what would I do to practice? I'm going to do another problem with you here, but I would go over, there is a file called review that I never actually went over, but I'll warn you about those. They usually are like really stretcher. They're like between R2s or R3s and R4s. So don't look at the review file and go, oh my gosh, I don't know anything, because those are usually really, really tough ones, like harder than we usually put on the test. But there are some problems there with the key. Last thought, throughout the homework, every night I've given you homework, and I've always given you a subset of the whole assignment. There's several problems in there that we skipped that were perfectly good problems, and will appear on the test, or ones just like it. So you could absolutely go back and do problems that we've skipped on each assignment. Just take the time to do them now. You could assemble your own review worksheet if you just were willing to go back and pull out the ones that I had you skip before and put them all into one document, and the key's there too. So you have stuff you can do. And would this be a smart one to study for? Yes. Why? Well, 2 reasons. I've told you before that this test has this test is overrepresented on the final. So like this chapter 9, the chapter you're about to be tested on, doesn't have a retake. Number 2, because it's at the end of the year and we don't have time to have you do a retake and the final, so it doesn't have a retake. We have a way for you to get points back if you bomb it, and that's through doing corrections. And you're not going to get all your points back though. Okay, so you can get some points back, but it's meant to just like salvage a kid who just randomly ends up failing the last test. So we don't want them to have that in their grade. So we'll give you a way to help, but it won't be a retake. Last thought is your final is coming, and what is one of the biggest things on the final? This stuff. So why not spend an extra night right now studying for the final and this test, and you get double points for it. It'll help you tomorrow, and it'll help you do better on the final. Okay. So what is the homework after tomorrow? 2 things. Number 1, you can work on the lab. I've given you everything you need to now to do the lab. You missed that at the beginning. So go do the lab. It's due on Friday of this week, but it's also like the only night you'll have time, like special time set aside, is tomorrow after school because you have nothing else. And the last thing is the take-home. I am officially going to move the take-home to, it was, in some places I said Friday of this week, in other places I said Tuesday. I'm officially moving the take-home to do Tuesday, as in not tomorrow, but a week from tomorrow. That gives you all that long weekend when you could do your take-home, okay? So your take-home is due on that Tuesday of finals week, and you'll have a long weekend where you can work on it. But don't curse yourself to having to do it all then. All right. So what's the last problem I want to do with you? I want to make sure you get what these mean. And there's different ways. You can use blocky, or you can just go like this. But that symbol is the sigma symbol. And that sigma symbol, you have to either know what it means if I give you one, or you have to make one. Let's say it was this. Would you please figure out the first 3 terms of this? Just the first 3 terms. Now the whole sigma thing is different than just a sequence of terms. You've been doing sequences for a long time. It's actually a command that you should not only find those terms, but then add them all up. That's what makes it a series. We're not going to test you on the difference between a sequence and a series. Even I get confused sometimes. But a series is a bunch of numbers that you are going to add up. A sequence is just a bunch of numbers, and usually they just ask you what's the 6th term or whatever. This little symbol in front is a sign. They're saying, hey, add these all up. All right, first term you should have got when you put a 1 in was 2 minus 5 is negative 3. Then you stick in a 2. Why? Because you're moving slowly from this to 5. So I'm putting in a 2, then I get 4 minus 5 is negative 1. And then I start realizing, oh, it looks like it's only going up by 2. And it is. So I can, in the last one, just do it in my head and say that it end up being positive 1. Now, if I want to just be extra careful, I might put the 3 in here, make sure. 6 minus 5, oh, yep, it's 1. There's the first 3 terms. Why do I like the first 3 terms? Only because now you can pretty easily look back and figure out how much is it going up each time. You know what I mean? If I only gave you the first 2 terms, you might think it was going up by 2, but then maybe that would be different. Well, this one actually does go up by 2 each time, so the common difference is called D, and that's 2. Why would you ever need that? Well, because if this was a big enough number, like 1 through 5, you might be able to just find all 5 terms and add them up. But what if I said 1 through 15? Do you really want to find all 15 terms and add them all up? No. Then you'd probably want to switch to a different formula. So I'm going to do that right now. I'm going to ask you to figure out, and I understand since I don't have a calculator for you right now, that you might have a hard time utilizing this formula, but at minimum, put all the numbers in the right spots, okay? So here's the formula you'd want. S sub n, which is standing for, in this case, the sum of a geometric that's been added up a certain number of times, which is n. And then they in the formula sheet are going to say 2a. Remember, that's really the first number plus the last number, because it's really a plus d times n minus 1. Nope, I'm wrong. Darn it. I'm doing the arithmetic. Sorry, erase that. That was arithmetic. This is definitely not arithmetic. Oh, wait, it is arithmetic. Oh, okay, sorry. Your form, your sheet would have been a lot easier to read. Sorry, I'll just write it. It's this one. I'm trying to analyze it and write it. 2a plus d times n minus 1. There, done. Sorry. Here's your formula you want to use. And it depends on knowing a few things like a. Do we know the first term? We do. D, do we know the D? We do know the D. N, how many terms are there? Well, since I started with n equals 1 on the bottom, it's really not that hard. Do you remember how I played with it sometimes and said, like, what if I started with 4 here and everybody thought that there'd be 11 terms because you go 15 minus the 4 and there wasn't 11 terms? Remember what it was? 12. Okay, but back to, I did start with 1, and if you ever get a chance to make one, you should start with 1. All right, here's what you should have put. What was n, the number of terms? Now I got you thinking, you just subtract these 2 and you'd get 14, but do you really think there's 14? No, it's 1 bigger than that, so therefore 15. So 15 divided by 2. And then 2a, well, 2 times what was the first starting value? 2 times negative 3 plus d, what was the common difference? What was it going up each time? 2. And then n minus 1, how many terms were there again? 15. There we go. And if you multiply that all out, you'd have your answer of what they added up to. Okay, now let's do one where you have to make a sigma. 6 times 3 is 18, dot, dot, dot. It's times 3. Can you make a sigma for that? And let's say that I only do 4 terms. And it's got a hard stop there, a period, as opposed to dot, 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 which would imply it goes forever. Can you make me one of these? Pause for a second. We only have like 1 minute left. Let's see if we can do it. Somebody's going to realize, I wish I had a formula sheet. I'll be your formula sheet. This is the one you'd want. Because it's geometric, you'd want the a times r to the n minus 1 formula. So here it goes. I'd go from 1 to 4, because there's 4 terms. Then I'd put this part of the formula right here, except I know A and I know R. What is A? 6. What is R? It was timesing by 3, so that's a 3. And there is your sigma. All right. You know what you should do, and I probably am going to be gone tomorrow with my back feeling as tricky as it is right now, so don't plan on coming in for any extra help in the morning. You know, I'll watch old review videos. Test is tomorrow. After that, labs due Friday, and a week and a day from now is when the take-home final is due.